All right. So this unit is, well, the next couple of units are a little different than what we've been doing. We're going to do some special topics here related to machine learning. And this week we're going to do humanoid robos. Humanoid robots. Let's try that. Humanoid robots. So we're going to look at humanoid robots. So I'm going to have you all research a humanoid robot and present it to class. Not the actual robot. I don't expect you to buy a robot and bring it to class, but present about this robot. We're going to do it in pairs. So we're going to pair you up and assign you to pairs for this. And so next class, which will be next Tuesday, you'll do a short presentation on your favorite robot here. So I'm going to just introduce this concept here. And talk a little bit about why we're talking about this and why I think humanoid robots are going to be a big deal in the next 5 years here. So let's look at a couple of these resources. That's interesting. I don't know why that link isn't working. Okay, I'm gonna play this parts of this video and we'll I can play it that loud, shoot the ads. Okay, try this again.
Robots are rapidly advancing at a rate quicker than expected. In this video, I will do a deep dive on the top humanoid robots that exist in 2025. Engine AI is a cutting-edge robotics company based in Shenzhen, China, that has quickly gained recognition in the global robotics industry since its founding in October 2000.
Okay, and so he's gonna go over some robots, and just so you note, what we're gonna want you to do eventually is to break into pairs. We'll do this today and sign up for a robot. So I have a bunch of robots listed here, and I think I have everyone in that video. If I'm missing one, we'll add it to the list here. And so what we want you to do is pick a robot here and sign up. And again, we'll sign you up in pairs here when possible. Okay, so again, when you're watching this, think, oh, I should, I want to do that, a report on that robot. And again, these are only 10, and we have more than 10 on this list, just so you know. So,
2023. The company specializes in developing robots with lifelike movement capabilities, setting a new benchmark for realism and functionality in robotics technology. Among its creations, Engine AI's SE01 humanoid robot stands out for its remarkably human-like gait and advanced motion control, achieved through the use of NVIDIA's Isaac Gym, a virtual environment that enables sophisticated AI training. This platform allows the robot to simulate and refine movements before implementing them in the physical world, resulting in fluid and natural locomotion that closely mimics human behavior. Engine AI's team, composed of 36 researchers from prestigious institutions such as UC, demonstrated impressive feats of agility, including performing front flips, a significant achievement given the difficulty of maintaining balance during such maneuvers. The company offers a diverse product lineup tailored to various applications. The SE01 is designed for industrial use, while the XA01 serves educational purposes, and the PM01 focuses on agile performance. These robots are not only functional, but also open source platforms.
Okay, I'm going to skip around a little.
Figure robot. Figure 02 is a cutting-edge humanoid robot developed by Figure AI, representing a significant advancement in the field of robotics and artificial intelligence. Standing at 5'6" tall with a payload capacity of 20 kilograms, the Figure 02 is designed to closely mimic human form and function, making it ideal for performing a wide range of tasks in environments built for people. This second-generation humanoid robot boasts impressive features that set it apart from its predecessors and competitors. The Figure 02 is powered by an electric system that allows it to operate for up to 5 hours on a single charge, with a custom battery pack integrated into its torso, providing 50% more energy than its previous iteration. The robot's mobility is enhanced by its ability to move at speeds of up to 1.2 meters per second and navigate complex environments with ease. One of the most striking aspects of the Figure 02 is its advanced AI capability, which enable it to perceive and understand its surroundings, adapt to changing conditions, and even engage in speech-to-speech conversations with humans. The robot's onboard vision language model, powered by 6 RGB cameras, allows for fast, common-sense visual reasoning, while its partnership with OpenAI has led to the development of custom AI models that drive its conversational ability. The Figure 02's dexterity is another standout feature, with its 4th-generation hands equipped with 16 degrees of freedom per hand, mimicking the strength and agility of human hands. This level of dexterity allows the robot to perform intricate tasks with precision, from manipulating delicate objects to operating tools and machinery. Recent demonstrations of the Figure 02's capabilities have showcased its action. Next, let's take a look at the Boston Dynamics Atlas robot. The Boston Dynamics Atlas is a cutting-edge humanoid robot that has become an icon in the robotics industry since its initial unveiling in 2013. Standing at 1.5 meters tall and weighing 89 kilograms, Atlas is designed with an emphasis on advanced mobility, dexterity, and a high strength-to-weight ratio. The robot incorporates titanium and aluminum materials with extensive use of 3D printing technology to optimize its frame for both robustness and relatively low weight. What makes Atlas truly remarkable is its impressive agility and physical capability, which have continually evolved over the years. The robot has transitioned from a partially hydraulic machine to a fully electrified robot, marking a significant advancement in its efficiency and flexibility. Atlas is equipped with 28 joints and advanced control algorithms that enable it to execute tasks with high precision while adapting to its environment. Its design allows for 360-degree swiveling capability. Enneagamma is an advanced humanoid robot developed by a Norwegian company, 1X Technologies, designed specifically as a home assistant capable of performing household chores and interacting naturally with humans. What makes Enneagamma particularly remarkable is its unique design approach that prioritizes human comfort and home integration. Unlike conventional humanoid robots with rigid mechanical appearances, Enneagamma features a soft knitted nylon bodysuit created using a Japanese Shimaseki machine, giving it a more approachable, closed look that helps it blend seamlessly into home environment. This soft exterior not only makes the robot more aesthetically pleasing, but also serves a practical purpose by preventing it from damage.
What is the biggest problem? Stress out all the things that I have to manage and deal with. Definite.
Damaging the fragile.
So here's one question I have with this whole thing. So if I had a robot who knew how to wash dishes and do my dishes for you, I would not be helping the robot, I don't think. I mean, why are you helping the robot do the dishes? I don't understand that part of it. I mean, I would help my spouse do the dishes and visit with her, well, actually, I did the dishes, but that doesn't matter. But she could help me do the dishes. That would be fine. But helping a robot, I did not, I don't grab. Okay.
Injuries to the robot. The robot features distinctive emotive earrings that light up when it is with the owners and provide visual feedback about the status, enhancing the intuitive interaction experience. Enneagamma's movement capabilities are. Now let's take a look at another company coming out of London. The HMND-01 is a next-generation humanoid robot developed by Humanoid, a London-based AI and robotics startup founded in 2024 by serial entrepreneur Artem Sokolov. Standing 175 centimeters tall and weighing 70 kilograms, this general-purpose humanoid robot represents a significant advancement in robotics technology designed to address labor shortages and enhance automation across various industries. The HMND-01 boasts impressive specifications, including a walking speed of 3.3 miles per hour, an average runtime of 4 hours, and a payload capacity of 15 kilograms. What makes this robot particularly exceptional is its modular design concept, allowing customers to incorporate different upper body look. Now let's take a look at a robot coming out of China. The Unitree G1 is a groundbreaking humanoid robot that has significantly advanced the field of robotics with its exceptional mobility, dexterity, and affordability. Standing at 1.32 meters tall, weighing approximately 35 kilograms, the The G1 was introduced as a mass production version in August 2024 by Chinese company Unitree Robotics. What makes the G1 particularly remarkable is its price point of just $16,000, making it one of the most accessible humanoid robots on the market and positioning it to compete with industry giants like Boston Dynamics and Tesla. The G1's design incorporates 23 degrees of freedom in its joints, with some models featuring up to 43 degrees of freedom, enabling it to perform complex movements with impressive precision. This exceptional joint flexibility allows the robot to execute intricate maneuvers such as jumping, spinning, climbing stairs, and even performing martial arts techniques. The robot is equipped with advanced sensors, including an Intel RealSense D435 depth camera and a Livox MID 360 LiDAR pump, providing it with 360-degree environmental awareness for precise navigation and obstacle avoidance engineering. Now let's take a look at Elon Musk's humanoid robot. The Tesla bot, also known as Optimus, is a humanoid robot designed by Tesla to perform tasks that are repetitive, dangerous, or undesirable for humans. Standing at approximately 170 centimeters tall and weighing around 60 to 73 kilograms, it's built to closely resemble human proportions and capability. The robot was first announced at Tesla's AI Day event in August 2021, with Elon Musk describing it as a general-purpose robotic assistant that could eventually become more significant than Tesla's vehicle business. What makes the Tesla bot particularly impressive is its integration of Tesla's existing automotive technology. It uses the same AI systems, batteries, power electronics, advanced motors.
Okay. Wanted to just get you kind of the feel of what some of these robots are in case your social media feed is not full of robots. And if your social media feed isn't full of robots, I think it should be. So, okay, let's go back and look at some of these. So why do I think robots, because we've been talking about robots since I was your age, and that's a long time. We've been predicting robots are just around the corner for a long time. So why do I think we are there? Well, we can see a lot of growth here, and this growth in what we often call physical intelligence here. So we've seen a lot of growth in language and how language are processed and even how some images are processed. But, you know, like this quote from NVIDIA's CEO, you know, the next frontier of AI is physical AI. Imagine a large language model, but instead of processing text, it processes its surroundings here. Instead of taking a question as a prompt, it takes a request. Instead of producing text, it produces action tokens. And again, we'll see this here in these models. And again, one of the things why we're bringing it in here, it kind of relates to how these large language models work, where remember, we take words and we tokenize them here. And, you know, we encode them. We talk about encoder, decoder. We encode them into these vectors. And then we process those vectors, and then at the end, we decode those back into words. And what we can do now is take actions, take text or something encoded, but then decode this into actions and how that works. So, also, you know, how is this different? I've worked some with traditional robots, and they're just a pain to work with. Just trying to program them to reach out and pick up something and set it down with the little arm is just incredibly difficult. You've got to, you know, first you've got to have some cameras that identify where this is located and stuff. And then you've got to, once you know where, you know, the XYZ coordinates in your plane where this is located, you've got to then calculate a plan for how you pick this up with your hand or your gripper or whatever. And, you know, you have a number of degrees of freedom. And there's this whole strategy for how you can plan to pick this up. So then you start programming your arm and you have this whole control system. So as you're moving, you then look at the plan and see if it's working okay. And then you can keep going on the plan. But again, often if it moves or whatever, you'll just miss it, or if something happens, you won't grab it correctly. It's kind of like, have you ever done those little grabber arm games? You know, in amusement parks or whatever. What are those called? You know, I don't know what those claw machines. Yeah, have you ever like tried to work a claw machine? How hard those are? It's kind of the same thing that you're trying to do with a computer there. So that's traditional robotics, and it's just really hard to do here. And again, the best we can do is very specific repetitive tasks in a controlled environment. So not in a house, certainly, but like in a factory here. But now we're seeing much more neural net driven, where we have a neural net driving and learning this whole process for us. The cost is coming down. So 20 years ago, a bad robot was costing over $1 million, and today we're looking at around $40,000 for some of these. So we've seen a steady decline in hardware costs here. We are spending a lot more money on these. This is just startup funding, so this isn't the big companies out there. This isn't Tesla. This isn't like OpenAI's money. That's separate. This is just startup money here. And just since 2020, you can see in the US and China, it's really grown. Now, this might suggest to you that China is not spending as much money as the US on robots. That isn't true. China just doesn't have many startups, these independently funded startups. So a lot of the Chinese stuff is more government funded or big company funded research and development here of these robots. Where in the US we have a bigger funding pipeline for startup companies, especially in tech. So to show you how far we've come, I'm going to go back 10 years to my favorite robot 10 years ago. This is Pepper, the robot. Introduced 10 years ago, but again, it's still in production. For even 5 years ago, you could people were still buying. In fact, there's a researcher who used to work here, Shia Khan, who now is at UMD, and she's worked a lot with Pepper robots there. So even just 5 years ago, she was buying Pepper robots, even less than that, I think, and running these Pepper robots. Very much humanoid, but again, notice no legs, just a wheeled base. A couple cameras, armed, but they can't actually grab anything. They're just to gesture there, and then a screen here, a touch screen to interact with the robot, because no voice interaction with the robot. Oh, well, let's look at another video of this. So again, 4 feet tall, 62 pounds, a 10-inch display, 2 cameras, a couple touch screens or sensors, 4 microphones. It can navigate around, has sonar and laser and bump sensors. So it's about as smart as like my vacuum, I would say, is currently. And I don't have a very smart vacuum. I mean, my vacuum is smart enough to drive around, vacuum my house and not hit too many things there. So here's a video. Let's see if this one's going to work. So again, this was like cutting edge 5 years. It was introduced 10 years ago and still pretty cutting edge 5 years ago before the pandemic.
Definitely from the community with machines and such roles and diversity of Tokyo. We're here to see how Americans are reacting to what was first US deployment. Can you tell me what I'm here to rest here? Thank you. How about coffee? Let's say you have 5 seconds from about maybe 5 feet to make an impression. This technology does that so much better than any signage would ever do, than any other sort of kiosk would ever do. The technology allows for it to recognize people and in fact all of them. How long before this technology transitions to something that's commonplace, or because most of the interaction we're seeing right now is never been up before. It's cute. I want to take a selfie. When?
Okay, so that's Pepper again, and they're still using research out there, but again, to me they seem very outdated given the current technology here. Again, like no feet, can't go upstairs, can't move. Again, basically, what can move wherever like your vacuum can move. So, okay, so what's underneath this that I think is important here? One thing I want to talk about is foundational models. You remember when we did convolutional neural networks and image recognition, like trying to detect whales or cancer and stuff like that? We could build them from scratch, but what we really found powerful was these pre-trained networks. They would take a big convolutional neural network and train it on a whole bunch of images and get a whole bunch of the filters pre-trained there. So we had things like MobileNet or VGG16 or stuff like that. They were all pre-trained, and then we could just modify those pre-trained models and get going very fast. And that's what we're beginning to see with robotics, because now robotics are now running these neural networks from across the whole thing here, and we're doing so. Like some things we're seeing in here, vision language models. So these are special models that are trained on both. So basically, it's a large language model with a vision encoder, giving it the ability to see here with these. So these are these kind of vision language models for this. So again, that's what you're seeing now in a lot of the AI systems. You can put in a picture and you can put in a prompt, and it can tell you something and sometimes generate a picture for you out of this here. So we're training a lot of these models. What you probably haven't seen is these vision language action models. They're set up to control robot actions through vision and language here. So basically, what they're taking is fine-tuning one of these vision language models by training it on robot trajectory data so that you can figure out, you can program what this is. So like this is talking about this sort of vision language model. So we're trying to integrate vision and language and some physical execution here. How are we moving? What are our actions going to be for these models here? So there's a couple that are out there. Google has their Gemini robotics platform. So this is their second iteration of it, and they've been training it on a lot of these actions. So it sees, you can talk to it, and it can move around. Let me just look at a couple of these videos.
We're bringing Gemini 2.0's intelligence to general purpose robotic agents in the physical world. To be helpful, robots need to be interactive, responding live to your actions and your voice. They need to be dexterous to complete your most complex tasks and they need to be general to understand things in your 3D world. And all of these capabilities need to work across different physical forms. We're bringing this together in Gemini Robotics, our most advanced vision language action model. Gemini Robotics is interactive.
And you put the banana in the clear container.
Notice how we move the objects and the model reacts and replans on the fly.
And you put the grapes in the clear container.
Our model's low latency means it can respond live to rapidly changing conditions and instructions. This same model can generalize to all kinds of applications where you can collaborate with the robot live. Gemini Robotics is dexterous. High dexterity tasks are some of the biggest challenges.
So places like Google are working on these foundational models here and training them. And again, they're set up to work on different physical environments. Like this is just two gripper arms, and be expandable. So again, you can take this model and move it to a humanoid robot or something like that. And you don't have to retrain everything for that here. So that's what we're seeing with these kind of idea with these robots. And they should understand language. You should be able to talk to them and work with them. So
Putting the pen with the other pencil.
and so again, they're supposed to be generalized. And I don't know. I have Alexa's at home. My wife is Apple and uses Siri some, and I use Google on my phone there. And they're getting better, but they're still really quite not, they don't generalize well, they don't answer questions, they're still very primitive. And so we're beginning, I mean, you see them integrated with large language models, and we see the same thing. Traditional robots, we are trying to program a robot just to drive around the hallways at St. Scholastic here. We couldn't just tell it where offices were. We had to program we had to figure out, like, for every office, we figured out 20 different phrases, exact wordings, go to Sabah's office, visit Sabah's office, can you visit Professor Alwan's office? And, all these different, we'd have to list out the 20 different ways you could say this and program it all in there. It was very specific, very hard to do, where these are much more general. So again, Google's doing that. Figure AI is also doing this. So Figure AI is largely funded by OpenAI here. So they have their Helix model for this. Let's just see if we can watch this.
Very first time that you've ever seen these items, I'd like you to use your new Helix AI and try to reason through where you think they belong, and then work together to put them away. Does that sound good?
It used to be all the videos for robots were always sped up 2 to 10 times because the robots were so incredibly slow that you couldn't speed up. I always remember there's an episode of The Big Bang Theory where they're trying to program the robot, and it takes them like 10 minutes to pick up this bag of chips and move it over there. And that's what it was like watching real time, actual, not sped up videos of robots was incredibly, it would just drive you crazy how slow they were. Where these now often aren't sped up. They seem slow to you probably because you're used to watching all the videos sped up. But the fact that these aren't sped up is pretty impressive here. Again, so they're building this large scale model here and generalized model. There, this Helix system for people to use. So those are these are these vision, language, action models. There's also just more generic robotics foundation models. So Covariant is a startup that released a version of it here. And then Pi Zero released a version recently. With their version and testing these models out and doing things. And again, they're trying to test out lots of different and train these on lots of different examples, lots of different tasks, lots of different visions and things like that. And again, different types of robot configurations for this. And so I don't know if you've heard about Groot that was just released in March by NVIDIA. So let's just watch Groot.
Isaac Groot is a platform of sim-ready data, simulation frameworks, and synthetic data generation blueprints, and pre-trained models. NVIDIA Isaac Groot N1 is an open generalist foundation model for humanoid robots. Groot N1 features a dual system architecture for thinking fast and.
So again, you can see this, and again, hopefully you can tie analogies to what we've seen with large language models, where we take language like here and we convert it into tokens, we encode it into tokens, but they're also taking sensor stuff and converting that into tokens.
Inspired by principles of human cognitive processing, the slow thinking system lets the robot perceive and reason about its environment and instructions and plan the right actions to take. The fast thinking system translates the plan into precise and continuous robot actions. While internet scale training data provides common sense and reasoning, it doesn't teach robots specific actions or control. So we need better data and more of it. Human demonstration data is limited by the number of hours in a day. With Groot blueprints for synthetic data generation built on NVIDIA Omniverse and Cosmos, we can exponentially multiply a small number of real-world data captures into a massive, diverse training.
And we didn't talk about this too much when we did vision stuff, but in the vision systems, there are ways you can take your images, and let's say you only have 1,000 images, you can take it and program them to like skew each image or rotate or move each image just a little bit so that they're not all identical and often generalized. And we've been able to do this a lot with images, and they're just talking about how we can now do this with these sorts of more complex systems.
Groot N1's generalization lets robots manipulate common objects with ease and execute multi-step sequences collaboratively. And even multiple embodiments. And with synthetic data generation and reinforcement learning, humanoid robot developers can post-train Groot N1 for their specific robot and task. The age of generalist robots is here, driven by developers building.
Okay, so again, they're talking about a lot of this where we're training not just in real life, but also basically in a video game, in a simulated world. So you can take, and again, you'll hear this mirror idea where you can take your robot, mirror it in a simulated world and train it in that. And that's, I mean, basically pulling a lot of what we know from game design. Because in game design, we've had physics engines and stuff like that in game design for a long time. And so NVIDIA, for example, knows a lot about running physics engines uh, and how you can set up these models to run in there. So if you want to see more, this is just from April 8th here, talking about NVIDIA awesome.
Today, this is a deep dive into a preview of what we saw in Jennifer's keynote yesterday, an introduction to building humanoid robots. We have.
So again, I've taken, this is that image I showed you earlier for this. This was their keynote, I think, last year, or when was this?
In the middle, Jensen, right? So the biological humanoid, in this picture, is still the smartest, but maybe someday.
Forgot to mark where I wanted it. Okay. Yeah, I don't have it, but I just wanted to talk, and I forgot the good picture of this, but one thing I wanted to just mention is that we've looked at large language models with transformers underneath them, and we've also looked at diffusion models where you take some random noise and you use that to generate an image, basically create an image. And these models are actually doing both here. So what they're doing is they have basically a transformer model here. They're taking their state, their actions and their language and feeding it into again, you can look at the self-attention, cross-attention. These are basically transformer blocks repeated here, and they're generating action tokens. And then they have a separate system that take these action tokens and generate smooth movement based on those. And this next part over here uses a diffusion model. So in the same way that you kind of generate a image from random noise all at once, and you generate all the pixels at the same time. Here, what we do is we have a set of actions we want to do, and we generate a smooth motion plan all at once, where we generate the smooth motion of how the robot is going to move around and stuff. So again, I think this video is very interesting. It's only an hour and 40 minutes if you want to watch it. So we won't watch it in class. Okay, so that's an introduction to humanoid robots. I think they're going to be the next best, a big thing. I don't know if I would necessarily trust me, though. I'm not really good at predicting technology. I remember when Google came out and telling people that Google was not going to go anywhere because anyone could do what Google was doing. I remember seeing the first web browser and saying, who would ever use a web browser? No one's going to want to see this stuff like that. So I don't have a great background or success rate at predicting technology. So we'll see. Okay, so discussion this week is just find anything you can about robots here and post it here or reply to it for that. And then what we're going to do today is do robot presentations. We want to pair people up and have them sign up for a robot here for this. So and then by next class, we want to do that here. So well, we figure out how we want to pair up. So if you want to pair up, you can pair up with anyone here or not. So no. Good question. A very nice question. I like that question. So we're going to pair up everyone in the class, online, asynchronous, all those people. Everyone's going to be paired up on this. And we have a lot of time because we have all of Easter break to work on this, and you can figure out how you want to coordinate with your partner on this. So, given that you have to choose a partner, do you want to, yeah, preferences on partners? Okay, want you to put, and then you want to pick a robot. So we've got two there. So, so Stefan, do you want to work with Joseph? Yeah, okay. And Emmanuel and Makita, you want to work together? Okay. Then we'll have that divided up. So put so you guys will get first picks on robots here. So figure out what robot you want and put your names as the two presenters for that robot. Okay. So again, once the people in class pick their robots and their teams, I'll assign everyone else in the class to pairs and also assign you to a robot here. If you want to switch robots, let me know before Thursday. How about? I know some people are sick today. I heard from 2 students who are out today. Alex and Andrew, do you want to be paired together or you want to partner with someone else?
That works for me.
So why don't you message each other, I think with chat or whatever, and talk. I can set up a breakout room if you want. Yeah, so there are rooms there, but why don't the 2 of you work together on a robot also? Sound good? Now, the other thing you want to do is there's a write-up where we want you to record your basic information before. So for the learning activity, there's a little research document that you open up, you make a copy of it, put your names here, and it's just a spot to take notes of this. You don't necessarily have to do all this or whatever. We do want you to start listing sources. And again, this is kind of outline. Can you find the cost of this robot? Sometimes you want, can you find some pictures of the robot, who's making it, description of them, name of the robot, start thinking. And you can modify this. But again, this is what you'll turn in for the learning activity, is this robot research kind of template. And that should hopefully inform your presentation. And so you can do it. I expect most people will do, just a Google Slides or a Canva or something like that for your presentation there. So that'll be on Tuesday. So on-campus students will present on Tuesday, April 22nd here. And if you're an on-campus student, you're not in today, you still are expected to present on Tuesday here. Online students, so if you're actually an online student, You just have to record your presentation by the end of spring break. So if you don't have class on Monday, I'm extending that to Monday. And again, you can decide how you want to do this. A nice way to do this is, I think, is just with Zoom there, because the two of you can Zoom and talk and do the presentation that way. Although if you just want one of the students to help do the presentation, that works out okay. One thing we do want you to do when you submit, besides doing the presentation, is submit a description of how you'd rate your contribution to the project and your partner's contribution of the project. So we want you to submit a partner evaluation on that stuff. So how do you communicate with your partner? How would you rank your contribution on this project? So, okay, I'll let you get going here, and I'll assign the rest of the people to teams, pairs. Just a quick note on presentations and videos. You're certainly allowed. There's some nice videos out there, and sometimes with robots, it's nice to show a short video clip. You know, I don't really want to see a 5-minute clip of your video, you know, of your robot. But again, if you want, and again, remember in YouTube, if you hit share, you can create a link to a specific point in the video where you've stopped it. So that's nice. You can, if you find a spot where you want, just put that link in your presentation, or just, you know, show that, you know, clip that you want. So feel free to include video in your presentations. Just limit the length. Okay, for students who aren't in class today, we have assigned everyone to a partner here. So if you look in the learning activity here, you'll see everyone is partnered up. On-campus students are partnered up with other on-campus students. Online students are partnered up with other online students. I did an initial assignment of students to robots here, but there you can, if you don't like your robot, feel free to change to one of the other free ones there. So like agility or sanctuary robots no one's assigned to the new Fourier one, the GR1, no one is assigned to that. So again, feel free to, if you for some reason don't or have trouble with the robot you are assigned to, feel free to switch your names. You can all edit this, so you can just copy your names down here and leave another robot blank if you want there. And again, each pair should work on a single presentation. Put the link in here in the top box, and then if you are an online group, we want you to put a link to the presentation, and then a video of it. Anyone on campus should be in class on Tuesday, a week from today, Tuesday, the 22nd, to do a short presentation. How long did I say how long I wanted these to be? Yeah, 5+ minutes. That's what I want. So, in my mind, 5+ minutes means like 5 to 7. If you're talking for 10 minutes, that's too long. So, all right. So that's the plan. If you have any questions, let me know. Again, reach out to your partner soon and try to coordinate with them. If for some reason you cannot get all of your partner or never get a response back, remember, you can then do your own presentation. But again, you do want to fill this out here. And when you submit your presentation, you want to submit this. Hopefully, most of you will be submitting something like we shared the work evenly, or I contribute a little bit more, my partner contributed a little more than I did. We want to try to avoid these incidences where I completed nearly all the tasks or all the tasks for this. And again, we do want you to communicate or tell me how you communicated with your partner, especially if there are issues communicating with your partner. You want to share that, and then how much of the work you did here. So, all right.